everyone and welcome back to EduNext Academy. I am Maani and today I am going to discuss about something different that is very different from your mathematics and geology. This is physics. Okay. Now you are going to not only face exam in NEET about your physics, but also you are going to face exam in advanced JEE and in JEE Main also. Because the students, those are facing not only NEET, they are also trying for advanced JEE and JEE Main. Okay. Now this today I will be discussing about our very interesting chapter on semiconductor device, that is diode. Okay. So let us discuss about diode. Now you might have seen, you might have listened about diode, LED, light emitting diode. Now this is time of Diwali and you are going to decorate your home with colorful lights. Okay, that lights are diodes. That is known as light emitting diode. Okay, so now let us let us start from very beginning. That is how these diodes are formed. You know conductor, which conducts electricity. Okay, you know insulator, just like your paper, plastic, and your wood type material, which does not conduct electricity. Whenever you want to protect some conducting element, you just cover it by insulating material. But semiconductor is that material whose properties lies in between conductor and insulator. Okay. Now again, semiconductor are again divided into two types. That is intrinsic and extrinsic. Basically, these are pure form of semiconductor. Okay. Semiconductor, germanium, silicon, germanium. There are at least, if you go in your periodic timetable, you will find 13 such elements which are actually belongs to this semiconductor category, but actually they are not used. Their property doesn't satisfy silicon and germanium. That's why this silicon and germanium, they are abundantly used in now for making a semiconductor. If you take silicon, it becomes only silicon and only germanium, pure form of germanium or pure form of silicon, that is coming under this intrinsic semiconductor. But when you add some impurity, then it becomes such kind of semiconductor which can be applied in many fields. Okay, so now we are just going to discuss about this extrinsic semiconductor. This extrinsic semiconductor are two types, that is P type and N type. P type semiconductor and N type semiconductor. When silicon is added with trivalent impurity, means aluminum, boron, like that, they have at least 3 elements in their outermost orbit, but silicon has 4 3 electrons in its outermost orbit. When they combine each other, they don't follow octet. So there is a deficiency of one electron. That electron makes a hole. And the deficiency of electron, that means hole, it is a positively charged particle. Similarly, when you add this silicon, that means semiconductor with pentavalent impurity like arsenic, potassium, etc., they form such kind of semiconductor which has excess in electrons. So the charge of electrons is negative. In this way, positive and negative charges, they develop in P type and N type semiconductor. But when you join these two type of semiconductor, it forms such a material which act as a 2 electrodes. That means one positive, another one negative. So they together form a device that is known as diode. Diodes mean two electrodes. Okay, so let us discuss about this diode. You know, if I draw a block diagram, then it is P and it is N. This is P type semiconductor, this is N type semiconductor. When I join by some technology, okay, they form a single material that is known as diode. So here positive, P for positive, your holes are majority charge carrier. Holes means deficiency of electrons. Holes are positively charged carrier. Your electrons are majority charge carrier. These are negative charge in nature. Okay. So now you know when they combine together, they form a single material known as diode. Okay. And if I give a electronic symbol, then this is the symbol of the diode, and this is positive polarity. This is negative polarity. This positive polarity is known as anode, and negative is known as cathode. Okay, so these diodes are various kinds, but today we will only go just like a simple diode known as PN junction diode. PN junction diode. Now, and we see how this diode conduct electricity whenever supply will be given. So let us discuss about the circuit I am going to draw here. This is a diode. Okay, this is plus, this is minus, this is anode, this is cathode. Okay, if I give a supply to it, for example 5 volt battery supply, even in 1 volt also the diode start to give current. That means it start to conduct. Okay, so this is positive, this is negative. Such kind of connection is coming under forward biasing condition. Okay, that means positive polarity of the diode is connected whenever positive polarity of the battery. Such type of connection is forward biasing condition, and the current start to flow from anode to cathode. Okay, now see, you know the direction of electron opposite to direction of current. For example, if I draw a block diagram, here P, here N, here electrons are majority charge carrier, here holes are majority charge carrier. This is positive, positive. You know, positive charge, they repel each other. That means it will repel the hole to cross the junction. This is the junction. This is known as junction. Okay. The hole will move from P to N. And similarly, the negative polarity of the battery, this is battery, it pulls the electrons move from N type to P, N region to P region. In this way, the electrons start to continue. The electron will move from N to P, and you know the current direction is opposite to the flow of electron. That means the current direction is opposite to the movement of the electrons. So in this way, the current move across the junction. Okay. Now, let us discuss some conditions where current should move. The current will move across the junction of diode when the voltage across the anode is greater than voltage across the cathode. Okay, this is cathode, this is anode, 2 electrodes. So when let us solve some examples which are already came in previous year's questions of your NEET and advanced JEE and JEE Main. Okay, now let us discuss some conditions, forward bias condition and reverse bias condition, where the current start to flow and when current doesn't flow. Okay, so let us discuss few problems here. Now let us discuss the question. The question is given that which connection will conduct the current. Okay, now when the diode conduct, when the condition is when anode voltage across the anode is greater than voltage across the cathode, in that particular condition, the diode will conduct the current. Now see, here in first case, the voltage across the anode is minus 10 volt and voltage across the cathode is minus that is 15 volt. So you know which one is greater? Minus 10 volt obviously greater than minus 15 volt. That means the VA anode voltage is greater than the cathode voltage. Obviously, if the condition satisfying for polar biasing condition and current will flow. So in first condition is satisfying. Second, you see here VA is 4 volt and VC, that means cathode voltage is 2 volt. That means 4 volt is greater than 2 volt. Both polarity same. So obviously the option B is also correct answer for conduction. Okay. You are not supposed to answer a single option. Okay. There may be multiple options which can satisfy the condition. Now let us see the C. So here VA is minus 10 volt and VC, that means cathode voltage, negative side voltage is 0 volt. That means this VA, obviously minus 10 is less than 0. So VA is less than VC. Okay. That means the condition C will not conduct the current across the diode. Okay. Now here also now see, I have just inverted. The question has just inverted the diode. Okay. Now this side is V anode. This is positive, this is negative. Okay. Now VA is minus 10 volt and VC is minus 5 volt. That means VA is less than VC. So this option number D will also not conduct the current because this is not coming under the forward bias condition. Rather it is coming under reverse bias condition. And there are so many questions. A tricky question will be there. You have to see both side voltage, which one is greater. According to that, you will decide whether the diode will conduct the current or will not conduct the current. Okay. Now let us discuss another question. Now see, this is very tricky question. Okay, critical, little bit more difficult than first one. You have to see. This is the supply voltage. 5 volt supply is there. Plus and minus sign. Polarity sign is that. Okay. Now both the diodes are in direction. Means this is positive. This is positive. Okay. That means if the polarity of both diodes matches with the polarity of the supply voltage, that means it is in the forward bias condition. Now see, due to this voltage supply, source voltage, some current will flow. That current, as this is a node, okay, this is called node. From the nodal analysis, we know that from this node there are two branches. This current will divide upper one and lower one branch. Suppose upper branch current is I1 and lower branch current is I2. Question is, find out if the diode is conducting current, find out the current in the circuit. How to find out the current in the circuit? You have to find out both the current. That means you have to find out I total. Okay. Now you know Ohm's law. E is equal to IR. This implies I is equal to V by R. Okay. So now see, suppose this is 1K. This is also 1K. 1 kilo ohm, for example. Okay. Now in the branch, the V is 5 volt. That means 5 by 1K. That means how many ampere? 1K means 5 into 10 to the power minus 3 milliampere. So here I1 is equal to 5 milliampere. Okay, 5 milliampere, because K means 10 to the power 3. If you take upper side, it becomes 5 into 10 to the power minus 3. Minus 3 means milli. Obviously current unit is ampere. Similarly, I2 is also V by R. Okay. I have just considered your diode voltage across the diode is 0. Means the diode, I have to consider the diode is ideal. The diode is ideal here. Okay. So now I2 is also will come as 5 milliampere. Because similarly high volt by 1 kilo ohm. Okay. So now total current I is equal to I1 plus I2. 5 plus 5, that is I is equal to 10 milliampere. Now you understand. That means in this particular case, two things we need to understand. What is the polarity of the diode whenever it is connected with the supply voltage? If both the polarity are matching with the polarity of the supply voltage, that means the diode is in forward bias condition. And you know, when diode is in forward bias condition, it will conduct current. Now the current is obviously coming, but in these two branches, there are parallel diodes are connected in parallel, along with the resistor is also connected in parallel. You know, current will divide both sides equally. So let this current is I1, this I2. You know, I is equal to V by R. So both the branches you got the current I1 and I2. You just add it up. That means I is equal to I1 plus I2. So current in the branch is equal to 10 milliampere. Such type of question is also coming in your advanced JEE or JEE Main exam. Let's see, if I reverse the direction of the second diode D1, D2, what happened? Now see, the diode D1 conduct because it is in forward bias condition. But diode D2, this is minus, this is plus, minus, plus, and plus, minus, these are coming in reverse bias condition. In reverse bias condition, current I is equal to 0. No current flow. Okay, this current will flow in the fast branch only. That means in that case, the current will be I is equal to only 5 milliampere. Because current will come, but due to reverse bias condition, this will not conduct. Current stop here. So the total current going in the circuit will get the path like this. Okay, so that current will be 5 milliampere. This kind of tricky question you may face in your not only in your NEET exam but also in JEE Main and in your advanced JEE. Okay. Now I think you understand this particular condition, this particular question, and in the next class also we will do lots of problem on physics. In digital electronics, in motion, electronic motion, and electronic circuit like this. So, if you find this video is helpful and you understand things, please prepare at your home. And also please don't forget to like, share, and subscribe to my channel because subscription is required. And my next notification will be reached at you soon. So stay with us. Thank you.